Now we're gonna find the moles for Na3PO4. So let's go over here to our calculator. Answer 35.60 times everything across, which is 1, which will leave us with the same number, and divided by everything from the bottom, which will be 39.997 times 3. So we're gonna divide this and multiply everything by the bottom. 39.997 times 3. And that will give, and also take note that we have to respect our sig figs. So here we are given 4 sig figs in the beginning, and that's going to be the amount of sig figs that we're going to be using for our results. So in this case, we will be given 0.2967 moles of Na3PO4. Okay, but let's move on with the grams of Na3PO4. Okay, so the molar mass, or we're gonna go again. What we want will end up at the top. So 1 mole of Na3PO4 equals to 163, with the molar mass that we found here will be 163.94 grams Na3PO4. So if we do the math again, we will have to multiply everything at the top and divide it by everything of the bottom. All right, so we go here to our handy dandy calculator, times 35.60 times 163.94 divided by 39.997 times 3. One moment. That will give us 48. Sorry, that will give us 48.64. 48, sorry. Didn't mean to put that 4 there. 48.64 grams of Na3PO4. So that is just for the first compound that is given for us. Now we got to go with the second one. Okay, so first, like always, we got to do our stoichiometry map so that we don't get confused or do any mistakes. So here, the element that the compound that we're going to use is H3PO4. All right, so let's continue. So we're going to go from mass of H3PO4 to moles of H3PO4 to moles, and we're going to use the same product as last time, Na3PO4 to grams of Na3. Oh, sorry, forgot to put a O in there. PO4. All right, let's highlight it so that we know what we're doing. And let's begin. So we see that we're giving 30.80 grams of H3PO4. All right, so we're gonna start with that. So it's gonna be 30.80 grams of H3PO4. And we go up here and check our molar mass for that specific product, which is again 163.94. So we go back here and write it down. 163.94 grams of My bad. My apologies. That would be 97.994. Sorry, guys. So that will be 97.994 grams of H3PO4. And that will equal to 1 mole of H3PO4 times. Now again, we got to look to the mole ratio. In this case, the mole ratio here is 1 to 1. So it cancels out. So 1 mole of H3PO4 and 1 mole of Na3PO4 times, now we're going to grams. Sorry, we have to first go to moles. So let's calculate that first before we go any further. So that'll be 30.80. And we see that it is multiplying times 1 again. So it cancels out. Divided over 97.994 times 1, which will just be 1 of, or just be itself. So we'll just get those numbers, and that will be 0.3143. All right, let's write that down so we have it noted. Equals 0.3143. And again, we have to respect the number of sig figs here so that we can get our proper calculations. Moles of Na3, sorry, PO4. And let's highlight it so that we know what we're talking about, so that we don't get confused. Okay, and now we can go towards the grams. So this will be 1 mole of Na3PO4. And once again, we go back and see what is the molar mass of Na3PO4. And again, it will be 163.94. So again, we go back to our calculator and insert these numbers. Once again, 30.80 times 1 times 1, 160 times 163.94, and we divide it by the bottom. So this will be 30.80 times 163.94, okay, equals 5,000. So whatever the number is the result, it doesn't really matter. Do not round yet. Always round it towards the end. So we're going to divide this number by 97.994, which this will give us in the end, this will give us 51.53. Already rounded. Okay, so here's the fun part. So we have these results here. Oh, sorry, didn't highlight this one. Okay. So now we have all these results right here. And so the question is, what do we do with them? And it's quite simple. So what we have to do here is compare which number is the smallest. We here have, for the reactant NaOH, has the capability to do 48.64 grams of Na3PO4 or 0.2967 moles of Na3PO4, right? Okay, moving on. We know those numbers. Now we look at the bottom. H3PO4 has the capability to do 51.53 grams of Na3PO4, or in other words, 0.3143 moles of Na3PO4. Now, we want to do a comparison between the two. By default, we can see that NaOH has a smaller number overall than H3PO4. We see 53 grams of Na3PO4 compared to 48.64 grams. So it leads us to conclude that NaOH, in this case, is the limiting reactant. Why? Again, it is the first compound that will be running out when this reaction is taking place. And by default, H3PO4 is the excess reactant. Okay, now we'll teach you how to get the excess reactant remaining. So now what we have to do is to get the limiting reactant to induce stoichiometry with the excess reactant. And this will be something like this. So we know that NaOH, it is the limiting reactant, correct? So 35.60 grams. So this is going to go of mass. This is going to be mass of NaOH to moles NaOH to moles of H3PO4 to mass of H3PO4. Okay. So we know that the mass of NaOH that was given to us is 35.60 grams. And we know that the molar mass of NaOH is 39.997. That will equal us to 1 mole. Oh, sorry. 1 mole of NaOH. Now, once again, we're going to look at the mole-to-mole ratio here. So here, the mole-to-mole ratio is going to be 1/3 because we're only here dealing with the reactant side. And here we're going to find first the moles, just for good practice. So we have 35.60 times 1, which will obviously be 35.60. And we divide that by 39.997 times 3. This will give us a total moles of 0.2967. Okay, and now we're gonna find the grams. And we go back to see how much, what is the molar mass of H3PO4. That will be 97.994. 97. Sorry guys, kind of nervous. 994 grams of H3PO4. Now we do the math once again. So we multiply 35.60 times 97.994. We get the answer, and we divide that by what's on the bottom, which will be 39.997 times 3. And that will give us a total of 27.07, with always respecting the significant figures. And that will be 29.07 grams of once again H3PO4. Okay, highlight it. Okay, so what we're gonna do here is, to get the excess remaining, we want to get this number and subtract it from the excess reactant that was given to us, the grams. So here I'm gonna move on to the next page. I will be going back and forth. So it was given 30.80 grams of H3PO4. Minus, again, what was given to us will be 29.07. Okay, and whatever we get, that's gonna be our excess remaining. Whatever wasn't able to consume in that reaction, or not consume, but to be whatever couldn't have a reaction with the rest of the limiting reactant. So that will be 30.80 minus 29.07. And that will leave us with 1.73 grams of H3PO4. So to recap, again, this will be our limiting reactant excess. So once again, let's go again and write down the answers. The limiting reactant and the excess reactant. So the limiting reactant will be NaOH. The excess reactant will be H3PO4. Okay, the excess remaining will be, as we just found out, 1.73 grams of H3PO4. The amount, or the theoretical yield, that can be made from this reaction it will be whatever the limiting reactant is, which in this case will be 48.64 grams. What was it? 48, sorry, 0.64 of Na3PO4. Okay, and the last thing that we're gonna find here will be the percent yield. The percent yield, the formula for that equals actual yield if it was even given to us. One moment. Oh God, the percent yield here. Oh man, it wasn't given to us. I'm sorry. But to say that the percent yield, let's say we get let's just make up a number. A percent yield that was given to us made from the excess reactant, or the limiting reactant was, let's say it was, let's just put 40. Let's just put 40. 40 grams of NaOH. That is your actual. That will be your actual yield. So the formula for the percent yield will be actual yield over theoretical yield times 100%. Okay, so based on what we have all that we need. It's just a matter of plugging in our formula. So this will equal, the actual yield will be 40.0 grams of NaOH over what we got here will be 48.64 grams. Oh, sorry guys, once again. Sorry. That will be of your product, 40.0 grams of Na3PO4. And what we're going to be doing, like I said, we're going to be doing the percent yield. Na3PO4 and Na3PO4. So we're going to do this operation. So 40.0 divided by 48.64 times 100, which that will give us, with respecting also the sig figs, the smallest amount of sig figs that we have here will be 3. So we only need 3 sig figs, which will leave us with 82.2%. And this right here will be your answer for percent yield. Let's just write a note here, percent yield. All right. Thank you for looking at my video. I hope this would help anybody who is inside of YouTube and was looking for a percent yield problem. Thank you very much. Have a great day.